Alright, in this video we're going to talk about slope-intercept form. I want to start with a simple example. Graph the line with a slope of 2/3 and a y-intercept of 0, -4. Then write the equation of the line. So let's start with the graph, and let's start the graph with the y-intercept. The y-intercept is just a point, 0, -4. We know how to graph points. We go 0 right and left, and we go 4 units down. So the y-intercept of this line that we're going to be graphing is right there. It's 0 and -4. Now what does the slope of 2/3 mean? Now if you'll recall, slope we called in a previous video rise over run. So in this case, our rise over our run is 2/3. So the rise of this graph is 2. And the run of this graph is 3. Now what that actually means is for every 2 units this graph rises, it's going to go left and right. It's going to run 3 units. So we're going to start at the y-intercept 0, -4. We're going to say for every 2 units, that's 1, 2 units up, this graph rises. It's going to run 1, 2, 3 units. So we're going to have a point right there, at whatever that point is. We started at our y-intercept, we went up 2 units and right 3 units. Now we could continue to do that. We could say, okay, we're going to go up 2 more units from this point, and we're going to go to the right 3 more units, and we're going to have another point over there. Now to get an actual graph of the line, all we have to do is connect the dots. So connect your dots as best you can. It always helps if you make your dots really big. And there is the graph of our line that has a y-intercept of 0, -4 and a slope of 2/3. Writing an equation for this line is actually really easy. All you have to do is pick out your slope, that's 2/3, and you pick out the value of your y-intercept. In this case, the y value of our y-intercept is -4. And all we have to do is write down this equation. Y equals, and you write down your slope, that's 2/3, and right next to the slope you're going to put an x. And then whatever this number is, whatever the value of this y-intercept is, we're going to write right next to that. So in this case, -4 or -4. And the equation of our line is simply y equals 2/3 x minus 4. And as usual, we always like to come up with the general formula for this type of thing. In this case, we want to come up with the general formula for how do you take a slope and a y-intercept and put it into this form here. It's pretty simple actually. Recall from our previous videos that we always have been calling the slope m. Now this is a new one, but what we're going to do is we're going to call the y value of the y-intercept, we're going to name that b. And what did we do to get this equation? We wrote the equation y equals the slope times x, which in this case is going to be now mx, and then we added in whatever this y value of the y-intercept was. So it's going to be mx plus b. This right here is the general formula for slope-intercept form. Alright, let's look at a couple of quick examples. Let's find the equation of this line that's graphed right here. Now it's easy to pick the y-intercept off of this graph, and that's where we're going to start. It looks like our y-intercept is right here, and it's the point 0, 2. So we have a y-intercept, and all we need now to find the equation of this line is the slope. So what we do is we pick 2 points that are pretty obvious on this graph. So for example, we already have this point 0, 2 that we know is right there on the graph, and it looks like this point right here is a pretty obvious point on the graph as well. So all we have to do now is count the rise and the run. So if we start at this point right here, we can count the rise between these 2 points, is actually going down 2 units. The vertical distance between these 2 points is 2 units. Since we actually counted down between these 2 points, our rise is just going to be -2. Our run, if we count from left to right between these 2 points, we're counting right 1 unit, so our run is 1. That means our slope, which is always the rise over the run, is -2 over 1. And of course, we don't need to write -2 over 1. We can just call that -2. So we have now the y-intercept, 0, 2, and we have the slope of this line is -2. Let's write the equation of the line. And just so you see it again, the general formula for slope-intercept form is y equals mx plus b. All we have to do is plug in our slope for m and the value of our y-intercept for b. So that's pretty easy to do. Y equals m is -2, leave the x there, plus b. And b, like our previous example, is just the y value of the y-intercept. So the equation of this line is y equals -2x plus 2. Let's do another example. Let's find the slope and the y-intercept of the line -4x minus 3/8. All we have to do is recognize that the number in front of the x is always going to be our slope. So our m value in this case is -4, that's our slope. And whatever comes after the mx term is just your b value. Your b value is, in this case, it's got a negative sign on it. It's -3/8. Now the only thing we have left to do is actually properly answer this question. So we're asked for the slope. So the slope is -4, and that's part of the answer. And the y-intercept is always a point. It always has both an x and a y value. This -3/8 is just the y value of the y-intercept. So the y-intercept has a y value of -3/8, and its x value, since it's a y-intercept, is always just going to be 0. So our y-intercept is 0, -3/8. This example was especially easy because it was already put into the correct form. The form of this equation was already in the y equals mx plus b form. In other words, the equation was already given to us solved for y. So y was by itself in this equation. However, what if we had an equation like this? What if we want to find the slope and the y-intercept of the line 2x plus 4y equals 9? Well, in this case, this is not in slope-intercept form because slope-intercept form is always has y by itself. So what we need to do is put this equation into slope-intercept form. And the way to do that is you just get y by itself in this equation. So to put this equation into slope-intercept form, we have to get y by itself in the equation that we're given. And we just use basic algebra to do this. We subtract 2x from both sides of this equation. And on the left, we're left with 4y. And it's most convenient to write this as -2x plus 9 on the right-hand side of the equation. You'll see why I wrote it in that order in a minute. But to get y by itself, now we have 4y, so we divide both sides of the equation by 4. And we have -2x divided by 4 plus 9 over 4. We can simplify this fraction. -2 over 4 is just -1/2 x plus 9/4. Now you can see that I ordered these terms in this way because what we have here is exactly y equals mx plus b. So it's easy to pick out that that is m and that is b. So to answer the question, the slope is -1/2, and the y-intercept is always a point again, and that point is 0, 9, Okay, just a couple of quick notes about slope. The first one is about parallel lines. If you have two parallel lines, it's pretty easy to see that they should have the same slope. They have the same rise over run. So the first rule is that parallel lines have equal slopes. I think that one's pretty obvious, but a rule that's less obvious is a rule about perpendicular lines. Perpendicular lines intersect each other at right angles, at 90-degree angles. And the rule about perpendicular lines is those slopes are negatives of each other, and they're also reciprocals of each other. So the official rule is perpendicular lines have negative reciprocal slopes. Now that may be a little bit of a confusing sentence, so to clarify, let's look at some examples of slopes of perpendicular lines. So let's call this slope 1 and let's call this slope 2. So if slope 1 happened to be, let's say, 2/3, then a perpendicular line would have a slope that was the negative of that and also the reciprocal. So the reciprocal of 2/3 is 3/2. Two lines that have a slope of 2/3 and negative 3/2 are perpendicular to each other. Let's look at another example. Let's say the slope of the first line is 2. Then the slope of the second line would be negative, and the reciprocal of 2 is 1/2. So those two lines would have perpendicular slopes. One more example. Let's say the first line has a slope of negative 8/11. The slope of the second perpendicular line would be not negative but positive now, and the reciprocal is 11/8. So those are just a few examples of slopes of lines that would be perpendicular. Okay, it's video quiz time. This one has two parts. The first part is find the equation of the line. The blue line is given right there. And the second part is to determine whether the following lines are parallel. And you're given two different lines and you have to figure out if they're parallel. Okay, good luck. I'll see you in class.